Namaste and welcome back to JEE Mathematics with Typical Monk. This is class 38, three-dimensional geometry. In 3 dimensions, a point needs 3 coordinates, and every line and plane can be captured in clean algebra. A line is fixed by a point and a direction. Its direction cosines, the cosines of the angles it makes with the 3 axes, always satisfying L squared plus M squared plus N squared equals 1. A plane is fixed by a point and a normal, the vector perpendicular to it, whose components are exactly the coefficients in its equation. Ix plus b, y plus c, z plus d equals 0. From these two ideas flow the angle between two lines, the angle between a line and a plane, and the perpendicular distance from a point to a plane. Learn the direction cosines, the equations, and the formulas for angles and distances, and three-dimensional geometry becomes clean, mechanical marks. Today, points, lines, planes, and their angles, one idea at a time. Here is what you will master today. First, points and direction cosines. Second, the equation of a line. Third, the equation of a plane. Fourth, angles and distances. And fifth, the line and the plane together, one idea at a time. Let us set the foundation. 3 dimensions. A point needs 3 coordinates, x, y, and z. Direction cosines. The cosines of the angles a line makes with the axis. Direction ratios. Any numbers proportional to the direction cosines. Master line. A line needs a point and a direction. A plane needs a point and a normal. Now look at the picture. A point in space. A point. P has 3 coordinates, x, y, and z. Direction cosines. L, M, and N, the cosines of the angles with the axis. The identity, L squared plus M squared plus N squared equals 1, always. Direction ratios, A, B, and C proportional to L, M, and N. Now, the direction cosines in full. The cosines, L, M, N equal cosine alpha, cosine beta, cosine gamma. The identity, L squared plus M squared plus N squared equals 1. Direction ratios A, B, C proportional to L, M, and N. The angle between two lines found from their direction cosines. Now, the equation of a line. A line, it needs a point and a direction. Vector form, O equals A plus lambda B. Not isthmus IVX minus x1 over A equals I minus y1 over B equals z minus 1 over C. The angle between lines from the cosine of their direction cosines. Skew lines, neither parallel nor intersecting. Now look at the picture. A plane and its normal. A plane. Its equation is a x plus b I plus c. Sus t equals 0. The normal. The vector A, B, C perpendicular to the plane. A point and a normal. Together they fix the plane completely. The angle between planes. Found from the angle between their normals. Now, the equation of a plane in full. A plane. It needs a point and a normal vector. General form. Ax plus b, y plus c, z plus d equals 0. The normal. The vector A, B, C perpendicular to the plane. Normal form. It uses the perpendicular distance from the origin. The angle between planes from the angle between their normals. Now the angles and distances. Point to plane. The perpendicular distance formula. Line and plane. The angle uses the sine of the direction and the normal. Two planes. The angle uses the cosine of the normals. Now match each form to its object. L squared plus M squared plus N squared equals 1 goes to direction cosines. R equals a plus lambda B goes to a line. A x plus bi plus cz plus d equals 0 goes to a plane. And the vector A, B, C goes to the normal to a plane. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. Direction cosines satisfy L squared plus M squared plus N squared equals 1. Correct. Statement 2. A plane needs 2 points. Wrong. It needs a point and a normal. Statement 3. The normal to a x plus b, y plus c, c plus d equals 0 is the vector ABC. Correct. So the answer 2 are correct. Statements 1 and 3. The trap is the plane in statement 2. Now, the 2 mistakes that quietly cost marks. The truth: direction cosines satisfy L squared plus m squared plus n squared equals 1. Direction ratios need not. The trap: confusing the line and plane angle with the plane and plane angle. The second truth: the normal to a plane is its coefficient vector, A, B, C. The second trap: forgetting to normalize direction ratios into direction cosines. Now test yourself. Answer in your head before the reveal. That is how G-speed is built. Here we go. Question 1. Direction cosines satisfy L squared plus m squared equals 1. Question 2. The vector form of a line or equals a plus lambda b. Question 3. The general equation of a plane ax plus b, y plus cz plus d equals 0. Question 4. The normal to that plane, the vector a, b, c. And question 5. The distance from a point to a plane, the perpendicular distance. Let us gather it all in one breath. A point has 3 coordinates, x, y, z. Direction cosines L, m, n, L, L squared plus m squared plus n squared equals 1. A line, a point, and a direction, r equals a plus lambda b. A plane, a point, and a normal, a x plus bi plus c, z plus d equals 0. Angles come from direction cosines and normals. Next class, complex numbers. Space, made algebra. 3-dimensional geometry is the moment coordinate algebra goes a third axis and learns to describe the world we live in. A point becomes a triple x, y, z. A direction becomes 3 cosines, L, m, n, forever bound by L squared plus m squared plus n squared equals 1. A line is then nothing but a point plus a direction, written r equals a plus lambda b, and a plane is a point plus a normal, written ax plus b, y plus c, c plus d equals 0. Its normal vector hiding in plain sight as the coefficients. Angles between lines and planes fall out of dot products, and the distance from a point to a plane from one clean formula. Master the direction cosines, the equations, and the angle and distance rules, and all of space becomes something you can compute. Next class, complex numbers. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time. You will crack G. I will see you in the next class.